Ladies and gentlemen, 7.5 is all about product properties. So we need to have these three properties memorized, right? The product property, product means what? Multiplication. So when you have log, any type of log of something times something, and you know what, it's probably easier to understand if we thought of these being in parentheses. Log of something times something, you could rewrite it as that log written 2 times log of that first one plus log of the second one. I know that sounds confusing. That would be called expanding. We are also condensing. Let me give you an actual example of how we would condense. Like let's say I had log, give me any base. Log base what? Log base 5 of what? 3? Plus log base 5 of what? Let's say x. Sure, why not? So let's say we had an equation, log base 5 of 3 plus log base 5 of x. Let's say it's equal to 0, all right? And we wanted to solve this thing. Now normally you would just look at log base 5 and you would raise both sides to become powers of base 5. But the problem here is that you have 2 logarithms base 5. So we can't just raise it up to be the power of base 5 because you'd still have a log in the exponent. So you just want one single log. So what we're going to do is use that product property to condense these to one single logarithm. So what we would do is simply put that log base 5 and this log base 5 together as one single log base 5. Now you take this and multiply it with that inside parentheses, so you'd have a 3x right there. Does that make sense? So this is an example of how we would use the product property to convert 2 logarithms. How come this is not working? There we go. 2 logarithms into 1 logarithm. But you'd have to multiply the m and the n, put them together. So right here, when we put the m and the n together, we have the 3 times the x together. That becomes 3x. And on this side, we'd have an equal to 0. And then you could get rid of that log base 5 because it's only one single log base 5. Then you could get rid of that log base 5 by raising it to become the power of base 5, which would cancel out, and raise this to become the power of base 5, which becomes 5 to the 0, which is really 1. And you end up with that 3x equals 1, which means the final answer would be x equals 1/3. So that's an example of what we're going to be doing today, or on this section 7.5. We're going to be applying properties to condense it, to make it smaller, to be able to get rid of logs, to be able to continue solving the equation. Before, we only had a single log base 5 and we would just easily raise it to become power of base 5. But now we have 2 of them, and that's why we condense with the property to be able to only have 1 to be able to get rid of it. Excellent question. The only time we could actually apply these properties is if you have the identical log base b, right? So like over here on this example that I did, I have log base 5 and log base 5. That's the only reason why I could take both of these log base 5s and write them as one single log base 5. If this was a log base 5 and this was a log base 6, you cannot put them together. You just can't do it. So you can't apply the property. Yeah, they have to be the identical type of logs. Quotient property. Quotient means divide, and that's why we have a log of m divided by n. That could be expanded by taking that single log, and it becomes 2 of those logs, right? And the first one goes here, and the denominator goes there. Most of the time when solving equations, we're not going to be expanding, making them bigger. We're going to be condensing. So whenever you have log base something of something minus that same log base something of something else, you could condense both logs to become one single log, and you put this first term divided by the second term. Should we see an example of that? I mean, you know what, let me just give, instead of giving an equation, let me just say if I had log base what? 3 of, let's just say x minus log base 3 of, let's say 5, all right? We do have log base 3 there, log base 3 there. If I wanted to condense it, I want to put them both to become one single log base 3 of, again, the minus implies quotient, the plus implies product. So the minus means that we're going to have this first one divided by the second one. So you would rewrite that as x over 5. So this up here is the same as this down here. It's just rewritten in its condensed form. That way when we have equations and we want to get rid of log base 3's, we could condense it. And then once we can condense it, we could get rid of this log base 3 by raising it to become power of base 3. And the last one's the easiest one, I would say, the power property. What that does is if you do have log of something to a certain power, that power could be moved out to the front to expand it, and it becomes multiplication of whatever n value is. Or backwards, if you do have something times log base b of m, that multiplication of n could be moved up to become the power, right? So power property is easy. It's where the power becomes multiplication out in the front, or the multiplication becomes a power. Down here we have the change of base formula. I'll talk about that later, especially because the calculators actually do different bases. You don't have to do common log like I had to do in high school. My calculators only had common log or natural log, base 10 or base E. You guys have those Casio calculators that actually do any base. You can do log base 2, log base 7. Back when I was in high school many years ago, I had to memorize this change of base formula. We'll talk about it later. Right now, let's just get used to these properties. Let's jump to the worksheet. And on this worksheet, I already made a video doing the odd ones. I want to do the even ones. So right here, we have log base 7 on both sides. We would like to get rid of log base 7, but the only way to do that is if you only had a log base 7 of something on the left and only a log base 7 of something on the right. It's clear that we don't have only a log base 7. We have 3 times log base 7. We don't want this 3 times out here in the front. So I'm going to use what property to make it a log base 7 without the multiplication of 3 in the front? Power property, right? We're going to take this multiplication of 3 and we're going to raise it to become the power of that 4, of that base 4. So now I really do have log base 7 of 4 to the third. And 4 to the third is really, what is that? 4 times 4 is times 4, 64. Okay, so now we have equals, and let's do the same over here. This multiplication of 2, we're going to make it a b squared instead of multiplication of 2. So we really have log base 7 of that b squared. And now that we have log base 7 alone on both sides, we could raise both sides of this equation to become powers of base 7. That way, 7 to the log base 7 eliminate. The 64 comes down. The equals comes down. 7 to the log base 7 eliminates, which means that the b squared comes down. Then you solve that equation however you can. It is a quadratic equation. There is no other b, which means I could get rid of that square by applying what? A square root. And normally when you apply a square root in an equation, you have b equaling plus or minus square root of 64 is 8. So that would imply that you have two answers, positive 8 and negative 8. However, remember logarithms, you can't do the log of a negative. If you try to do log base 7 of negative 8 right here, that would not work. It would say error on your calculator. So the answer should just be b equals 8, not including that negative. That would be an extra answer. So b equals 8. Let's jump to number 14. So here we go. What properties could I use to make this a nicer equation? The first one, the product property. Again, whenever you see a plus sign, you got to think product property. Whenever you see a minus sign, you got to think quotient property. Whenever you see multiplication out in front of the log, you got to think power property. Okay? So there's no way around it, guys. You have to memorize those 3 properties of logarithms to be able to condense, to be able to solve. So right here we do have the plus sign. We are going to be doing the product property. We have log base 6 and log base 6. Let's condense it and make it one single log base 6. And of course, we will be multiplying the 2c and the 8. So you might as well do that. You don't have to actually write it. Just do it in your head. 2c times 8 is 16c. So we have log base 6 of 16c equals that same log base 6 of 80. So we're going to raise both sides of this equation to become powers of base 6. They will eliminate. your new equation becomes 16c equals 80. You're going to divide by 16, and we get our final answer, c equals 80 divided by 16. That could be reduced by 8, and it'll become 10 over 2, which becomes 5, correct?
Yes.
So c equals 5. Jumping to number 16. Quotient. Absolutely. We see a minus sign. We're going to use the quotient property. And again, the logarithms have to be identical in order for you to apply any property. So you have log base 2 on both of them. That's great. Write it as one single log base 2. And of course, the quotient means division. So you're going to take this first item and divide it by the second one. So you're going to have q divided by 3. And it does equal that other log base 2 of 7. We're not doing anything to that guy. And of course, because we have log base 2 on both sides of this equation, you could raise both sides of the equation to become powers of base 2. That way, 2 to the log base 2 eliminate. 2 to the log base 2 eliminate. Our new equation becomes q divided by 3 equals 7. So I simply multiply by 3, and I will get q equals 21. Number 18. Which properties am I going to apply on number 18? Power and then quotient. That's right. So let's take this multiplication of 3 out in the front, and with the power property, make it a power on that 2. So I really have log base 8 of 2 to the third. What is 2 to the third? That is 8. Wow, that makes it interesting. Because log base 8 of 8 is just 1, right? We still have minus log base 8 of 4 over here. Equals log base 8 of b. Now, for the sake of continuing with the practice of quotient property, I'm not going to eliminate this. I'm not going to make it a 1. I want to use the quotient property because of that minus sign. Put them together as one single log base 8 of the first one divided by the second one. And it works out beautifully. 8 divided by 4 is really 2. So you really have log base 8 of 2 equals log base 8 of b. So raise both sides to become power of base 8, and they will eliminate. So you have 2 equals b, and that should be your answer. b equals 2. Number 20 is starting to get more fun. What product? What property am I going to use on this one? Product, right? Because of the plus sign, I want to condense this log base 4 and that log base 4, condense it as one single log base 4. But of course, I am going to have something times something in there. This x right here times that 2x minus 3. So let's write it out. X times 2x minus 3, which means I need to distribute. So inside this log base 4, I will have a 2x squared, and I'll also have a minus 3x inside the log base 4. And yes, it's equal to log base 4 of 2. So now we could raise both sides of this equation and become powers of base 4. That way that eliminates, this eliminates. We will have a quadratic equation, 2x squared minus 3x equals 2. And we need to solve this quadratic equation. So this is where we use our semester 1 skills. We first want to set it equal to 0. So we will have 2x squared minus 3x minus 2 set equal to 0. Now from here, we identify our a is 2, our b is negative 3, and our c is negative 2. And we could use the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Or we could try to factor, split, and solve. What do you guys say? Factor, split, and solve. Even though the a value's not 1, which means we have to use that pretty long process on factoring, it'll serve as a good review from semester 1. Step 1 is to multiply a times c. That's really 2 times negative 2. That's negative 4. Step 2 is to think of the multiples of negative 4, like negative 1 times 4 or like negative 2 times 2. Those are the only possible ways of multiplying numbers together to get negative 4 besides changing the signs. So if I combine negative 1 plus 4, will I get that negative 3x or that negative 3? It doesn't give you a negative 3, it gives you a positive 3, which means you have the right numbers, just the wrong signs. So the actual pair of numbers that you want is positive 1 times negative 4. So this is the correct answers for step 2 on that long factoring process. I hope we remember step 3, which was setting it up into your answer format where you put ax and ax on the first part of your binomials. So ax is clearly 2x right here, 2x and 2x. And where do we get these other numbers from? From the pair of numbers from step 2. They just come right down and in here. Plus 1 minus 4. Now if you don't remember semester 1, you probably don't remember any of this. I apologize. It's probably easier for you to use the quadratic formula. The fourth magical step on this factoring method is to reduce the binomials by whatever you can. So on this first binomial, there's nothing to reduce by, so you would leave it as 2x plus 1. There's nothing in common with the 2x and the 1. But on the second binomial, you can reduce both by 2, and 2 divided by 2 is 1x, and 4 divided by 2 is 2. So we have factored. So it's still equal to 0. And now that we've factored that we have something times something and it equals 0, we could use the zero product property to say that that first something could be 0 or the second something could be 0. So the first one will give us x equals negative 1/2 if you do that math correctly, and the second one x equals positive 2. So we get 2 possible answers, and the reason why I say possible answers is because if I plug these back in and I end up with a negative right here, then it can't be a real solution. All right, so the negative 1/2 plugged it in. If you plug it in right here, it won't work because you can't do log base 4 of negative 1/2. You can't do log base 4 of any negative number. So that x equals negative 1/2 is definitely an extraneous solution. Don't put it as part of your answer. Let's also double check the 2. If I plug in the 2 right there, that's fine because you could do log base 4 of 2. It's positive. Right here, will it work? Let's see, 2 times 2 is 4. Yeah, 4 minus 3 is positive 1. You're good. So the answer should just be 2, not negative 1/2. Jumping to number 22. We're going to use what property? Quotient. Because of this minus sign, we're going to be using the quotient property. So we're going to take this common log and that common log and write them together as one single common log. And of course, we need something divided by something in here. That first something, the y, is going to be divided by that second something, the binomial 2 minus y. And yes, it's equal to 0. So we want to solve for y, we want to get rid of that log base 10. So we're going to raise it to become a power of base 10. And what you do to one side, you must do to the other side. Raise it to become the power of base 10. So what we really have here is 10 to the log base 10, which eliminates. And we have 10 to the 0, which becomes what? 1. So we have y divided by 2 minus y equals 1. A lot of people freak out with this equation. This is algebra 1 right here. Anytime you have any fraction and you want to get rid of it, simply multiply by the denominator. All right, so if you had 3/5 and you want to get rid of 3/5, multiply it by 5. You have 1/2, want to get rid of the 1/2, multiply it by 2. Right here you have y divided by 2 minus y, so let's multiply by that denominator 2 minus y. Now what you do to one side, do to the other. And right here they will eliminate. You have a nice beautiful y left over. Y equals, and if you distribute, nothing will change. It's still 2 minus y. So let's solve this thing by getting y's to one side and get rid of that minus y by doing a plus y. I will have 2y equals 2, which means that y equals 1. So there is my answer for number 22. Moving on to number 24. What property am I going to use? Quotient, right? That minus sign is quotient. If it were a plus, I'd be using a product. If you had a multiplication of a number in front of the log, I'd be using power. So yeah, the minus sign implies quotient. So you have that single log base 2 right there, and that log base 2 right there. Let's rewrite both of them as a single log base 2 right here. And we will be dividing. The two things that we are dividing are the first one divided by the second one. So it's going to be x plus 4 divided by x minus 3. And it is equal to the number 3. So how do I get rid of this log base 2? Raising it to become the power of base 2. And what I do to one side of the equation, I must do to the other side of the equation. So I have 2 to the log base 2, which eliminates. My new left side of the equation is x plus 4 over x minus 3 equals 2 to the third. What's that? 8. It's definitely not 6. It's definitely 8. And once again, we have a fraction. We don't want a fraction. What are we going to do to get rid of that fraction? Multiply by what? That's right. X minus 3, the denominator. We do to one side, do to the other side. So yeah, right here, x minus 3 cancel out. I have x plus 4 equals, let's distribute 8 times x is 8x. 8 times negative 3 is negative 24. Now let's solve this thing now the way we would in Algebra 1. Subtract x. We will have 4 equals 7x minus 24. Let me write that up here. 4 equals 7x minus 24. And then we would add 24. You'll have 28 equals 7x. Final step, divide by 7. X equals 4. It's a lot of work. And of course, just briefly check. If I plug in a 4 right here, do I end up with a negative? No. If I plug in a 4 right here, do I end up with a negative? No. So that's a good answer. X equals 4. Last question, 26. What property are we going to use? Product. And over here, what properties are we going to use? Power and then product. That's right. Okay, so let's use product on the left side. Log base 5, write it as a single log base 5. And of course, we will be multiplying the 10 with the 12. Might as well do that. 10 times 12 is 120. Now let's go to the right side. We said we're going to take this 3 and use the power property to put it up here as the power of that 2. So on the right side, we're going to have log base 5 of 2 to the third, which is really 8, plus log base 5 of a. And on the right side, I will now condense log base 5 and log base 5 with the product property, write it as one single log base 5 of 8 times a. 8 times a. So I really have log base 5 of 120 equals log base 5 of 8a. You're going to raise both sides to become powers of base 5, which will eliminate both of those. You have the simple equation 120 equals 8a. If you divide both sides by 8, you end up with 15. Thank you. A equals 15, 15 equals A. Ladies and gentlemen, we've done all the even ones on this worksheet. I will upload a video explaining the other ones. You already have all the answers on the back. Please make sure this is complete. We will have a quiz on this stuff at some point this week.